Hi, I'm Chad Lawson. This is the Internet, and you're watching Verbose Mode. Hi, I'm Chad Lawson. Welcome back to Verbose Mode. Clearly, this is not the actual Internet, but there's a TV show in the UK called The IT Crowd. And in it, the two main characters, who are very tech geeky, have a boss who is very much not, and they decide to play a prank on her. And I have a really great little clip to show you what I'm talking about.
What is it?
This, Jen, is the Internet.
So a few years ago, when I was working in a technology company, I saw that, I thought it was hysterical, and I wanted to build my own. So let me show you this is version 2.0 of my internet box. And you can see the spasming I'll explain in a second. But this is version 2, and as you can see, that there's actually nothing inside the box. All of the actual components are here in the lid. I've got my battery, my breadboard with a chip on it, and the LED. Now, the chip in this particular version is called an AT Tiny. It is the smaller version of the chip that you'll find on most Arduino Uno type of boards. So this presented its own challenge in that I had to be able to program it while on a breadboard without the rest of the stuff that makes a Arduino so easy to use. Speaking of which, like I said, this is version 2.0. The sticky adhesive you see at the bottom here is because the first version used this. This was my Arduino Uno, and you can even see right now it's got a little light that is just blinking on and off. Any Arduino that you buy is going to come with a program built onto it called Blink, and it's also one of the first programs you'll find in the examples page. And all it does is it takes the built-in light that you'll find on an Arduino board, turn it on and turn it off. On the Uno, that's tied to pin 13. So anytime that I'm using pin 13 for something else in one of my other sketches, such as making a buzzer or moving a motor, anytime that I turn that pin on, the light comes on. And just to show off, I can take a standard LED here and plug it into pin 13. And just along with the light on the board, the LED that I've plugged in here turns on, off, on, off. And all the program is doing is just, as it goes into the loop, it turns it on, waits for a second, turns it off, waits for a second, turns it back on, until you turn power off. Now, the version that is in here is a little bit different. When I wrote the program to go in here, I made a slight change to that program. I put in a nice little Easter egg. Every single time that it goes to blink, it picks a random number between 1 and 100. And if that number happens to come up as 42, the answer to life, the universe, and everything, then it starts blinking a message in Morse code. That was that little flickering you saw at the very beginning. That Morse code message is the numbers from Lost. So I have 3 nice little examples of nerddom all in one particular box. Now, when I took this to my last job, one of my coworkers freaked out. She instantly recognized it as, oh my gosh, it's the Internet. And we had to explain to some people it wasn't actually the Internet. It didn't need to be in the security closet or anything like that. But she absolutely loved that and loved the show as well. And she's recently taken on a new job in another state. So I wanted to build her own copy of the Internet to take with her. And I decided, though, that I didn't want to use another AT Tiny or an Arduino. I wanted to make it even simpler and have a longer battery life. So I started using a 555 timer chip. And I have this wonderful little book from Radio Shack from way back in the day. And inside here is a schematic for a basic A-stable circuit. And here's that schematic now. And the only programming, if you will, that is involved is choosing the 3 values that you see of the components on the left, R1, R2, both resistors, and C1, the capacitor. And the value of the capacitor, C1, determines how frequently it goes from an on-off state. R1 and R2 together determine how much of that time is spent with the light on in its high state, and R2 determines on its own how much of that time is spent at the low state or the off state. So I put together a nice little breadboard, similar to the one you saw inside there. Put together a breadboard, got it all wired up, verified that everything is exactly the way that I wanted it. I even tested it on a simulator on my iPad. And when I hooked it all together, I've got this, I'll show you this on the overhead here. Got it all hooked up and ready to go, plugged in power, and my LED turned on and stayed on. Didn't do anything else. So here's the schematic, here's the board I should say. I've got my R1, R2, and C1, and I made a couple of mistakes with this board besides the fact that it didn't work. I decided to put the components in the same physical places as they showed in the schematic, and it proved that I had to start moving a lot more wires and connecting things at odd angles just to be able to make it work. And I realized this was not the most efficient way of doing it. But the other mistake that I made is somewhere along the way, after a lot of time with a oscilloscope and a multimeter, I found that the connection between R2 and C1 was broken. And I thought, okay, well, would that actually cause the problem that I was seeing? So I went back to my simulator, and let me bring this in on my iPad. This is a program called iCircuit, and it allows me to put together a board or a circuit and test it out here. And you can see that I've got R1, R2, and C1. And these values do here in this scope exactly what I'm hoping for. It goes on, it goes off, it goes on, over and over again. So if I'm right, if I was right and the connection between R2 and C1 was broken, I can simply delete this wire. And now over here on my scope, it turns on and it stays on and it stays on and it stays on. Okay, so I found the problem. So now what I need to do is just go back to the drawing board, as it were, or in this case, back to the soldering table, and build another chip, or build another board. I just need to make one and make it correctly. This time my plan is I'm going to put the components closer to the actual pins they need to connect to on the chip, rather than trying to make them look just like the schematic. But while I was going through that whole troubleshooting process, while I was trying to figure out what was broken, I was watching some videos on YouTube in my watch later queue, and one of them was this very nice long documentary about the history of Las Vegas. And in it they showed, they have one section in there where they show all the different little marquee lights with the blinking LEDs, or blinking lights, and I just love that aspect of Vegas. I've always been a fan of Vegas, but those blinking lights really always get my attention. And it got me to thinking about, well, these lights in Vegas predate an Arduino, they predate the 555 chip, so how is it that they were able to make all these lights blink? And it reminded me of the first time I wondered that. One of my favorite movies, and don't judge me, I'm a giant nerd, I'm fine with that, is The Last Starfighter. And there's one scene where Alex is standing outside the trailer park, and the sign for the trailer park has these lights, Starlight, Star Bright, and at the top is the little star with its starburst pattern turning on and off. And I remember when I saw that movie as a kid, I asked my dad, how does that light work? How does it turn on certain things over and over again? And at the time, I thought he was just being coy, and when he said, "You'll have to figure that out for yourself someday." Now I realize he just didn't know and didn't want to say that. But eventually, I ended up figuring out, and for me, that kind of aha moment was just actually a few months ago. I think it was sometime last year. I was at a coffee shop in Milwaukee called Alderaan Coffee, and they have this giant marquee light inside on the back wall with an A for Alderaan, and the lights turn on and off. And what's really nice is they actually have the control box with a clear panel, so we can get in close to it and take a look. And there's a motor that's turning, and it's got two separate knobs. And these knobs reach high and low points. They flip mechanical switches to being on or off, and that determines what lights come on and off. And for me, it was that aha moment. I was like, okay, now I understand The Last Starfighter. There's more to understand about Last Starfighter, but I understand the Vegas lights. It's one more arrow in my quiver, as it were, on how to blink lights on and off. And I started thinking, now I have multiple ways of blinking lights. But the other technique that's kind of in my nice little repertoire is from this book, another one of my Radio Shack books. This one's called the Optoelectronics Circuits. And the schematic I have in here is called a dual LED flasher. And it's another nice little simple schematic. It's got two transistors you see toward the top, the different resistors and capacitors down the way to their LEDs. And as power flows through, it turns on one of the transistors, which sends power to an LED, which then sends power to the other transistor, and it keeps going back and forth, turning the lights on and off. And a great example of that is a few years ago, I joined Big Brothers Big Sisters. And my little brother loves electronics and loves soldering projects, so I bought two of these. This is a Velleman kit. I'm going to put this up on the overhead. And what's really nice about this particular circuit, besides I love the fact that it's this 3D shape, it's two circuit boards put together to do this. But I have my resistors, my transistors, and my capacitors, just like in the dual LED flasher, that just simply go alternate back and forth between half the lights on, half the lights off. It was a fun little kit to build. I don't remember how much they were, but it was a nice little inexpensive project to show another way of blinking lights. And it got me to thinking about all the different tools we have to build to blink, either single or groups of chained together lights. So I have my motors from the Vegas and the Alderaan methodology. I have my resistor transistor blinking lights like in the tree. I have my 555 chip, which is actually just the next evolution of the Christmas tree. And now I have my Arduinos. So it's just great to know that we have all these different techniques for blinking lights. And I've already received some different questions on other ways to do it, and we'll talk about those in future episodes. But if you like the show, please give us some comments and some feedback. If you have any questions, let us know. You can find us on Twitter at Verbose Mode TV. You can subscribe to the YouTube channel at Verbose Mode TV, and you can sign up for our mailing list at our website, verbosemode.tv. Thank you for tuning into Verbose Mode. Look forward to seeing you soon.